Good morning, Year 6. I hope you're all safe and well. Today is the 9th of June 2020, and today we're going to be reading and interpreting a line graph as part of our new unit on statistics. So, I'd like you to write down today's date and learning intention, and we shall begin. So, for today's lesson, you will need a pencil, paper, you'll need your thinking hats on, and you're going to need the worksheets which were emailed to you this morning. And for some of you, if you want to do some additional work, you'll need your Mathletics login. Check. So for our starters this week, we're going to be focusing on percentage and finding the percentage of an amount. Now, I've made it a little bit easy for you because the advice that you'll need to help you find the percentage of an amount is shown around the table. So where it says 10% of, you can see that's written in black. And if you look around the table and see what other words have been written in black, it tells you what you need to do. So to find 10% of an amount, you need to divide that amount by 10. So you'll need to find 10% of 30, 80, 94, 480, and then do the same with the 40%. Okay, once you've done that, write in your answers and we'll go through the answers on the next slide. So I did something slightly different with this lesson. I've given you 10 minutes in order to complete that rather than 5 minutes. So see how much of that you can get done in 10 minutes. You need to pause the video here. Excellent. So here are our answers. To find 10% of 30, we divide that by 10. So 30 divided by 10 is 3. Now we know 10%, that can help us find 20, 30, 40, 60, 70, 80, 90%. Okay? So if 10% is 3, then in order to find 40%, we know that to get from 10 to 40, we have to multiply 10 by 4. Yeah, 10 times 4 is 40. So we do the same with the amount. 3, and we take the 3 and we multiply that by 4. 3 times 4 gives us 12. Okay, so once you've worked out your 10%, you can use that to help you with so many other things. You can even use your 10% to help you with 5%. So if we know 10% is 3, well, what do we have to do with 10 to get to 5? That's right, we halve it. So we do the same with our 3. What's half of 3? It's 1.5. We know it's going to be a decimal number because it's an odd number. Now we know 10%, 40% and 5%, but 40% is not going to help us with the 15%. Instead, with our 15%, we know 15 is made up of the numbers 10 and 5. So we take our 10%, we take our 5% and we add them together to find 15%. To find 1%, we divide by 100. Okay, so to get from 100 to 1, you have to divide by 100. So we do the same. Okay, 30 divided by 100. Well, we know 30 divided by 10 is 3. It can't be that. We need to divide it so it moves 2 decimal places to the right. So our answer there is 0.3. And to find 16%, well, we've already found 15 and 1%, and we know 15 plus 1 makes 16. So to find 16%, we can do 4.5 plus the 0.3 to get 4.8. Well done if you managed to get all of that row right, and then you would have done the same with each of the other rows. So well done if you managed to get those, and don't worry if you didn't, because over the week we're going to break it down even more. Now, let's get started. We have seen some charts and graphs in our maths lessons, and also you would have seen some in the world outside school. So you'll remember yesterday I set you a task to look for how statistics are reported in the news and how they're reported in magazines, and to look for different examples of statistics in the real world. I want you to have a think about the types of charts and graphs that you saw and that you're familiar with, and just have a think about the way that you could describe each chart and how the graph, each chart or graph, and how it represents information. Excellent. So this week we're going to be focusing on a line graph. And a line graph is a type of graph which features points that are connected by a line, just like the name says. Line graphs show how something changes, either over time or as something else changes. They show the relationship between two sets of data. But what is statistics? We know we've talked about line graphs and we've gone into a little bit of that, but hopefully you looked up what statistics are. And statistics are a branch of mathematics which looks at the collection, interpretation and analysis of numerical data. So to put that simply, statistics is looking at numbers which have been collected, okay, and then trying to understand it and look at it in further detail. Examples of statistics, as we've talked about, could be a line graph, but some of the other examples of statistics could be a pie chart. Statistics can be shown using a pie chart. Statistics can be shown using a bar graph. It can be shown using a pictogram. So there's so many other ways that you have come across already and that you'll see whenever we're trying to report or show numerical data. So looking back at our line graph, we're going to look at a specific type of line graph called a time graph. And a time graph is a line graph which shows how data changes over time. It can be represented as a line, or you can use bars as well. So now we know what a line graph looks like, we're going to have a go at seeing how a line graph is used to record information. So let's look at a scenario together. Camille took part in a sponsored cycle ride. During the afternoon, his fitness tracker recorded how far he had cycled. Here is the table of data showing how far Camille cycled over 2 hours. How would you represent this data as a graph? So we can see from looking at the data that has been collected, we can see that Camille started riding at 1400 hours, which in 12-hour clock would be 2 p.m. We can see that he finished riding at 1600 hours, which is 4 p.m. In that space of time, he travelled 5.4 kilometres in 2 hours. And we're going to have a think about how we can show where he was at each stage in his journey using a type of graph. So think, how would you represent this data as a graph? We could use a line graph. Camille identifies that the data shows the change in how far he cycled over the afternoon. Perfect. It's the perfect thing to show. Perfect. We'd use a line graph to show exactly what it is that Camille is trying to show. He knows that a line graph is used to show changes to measurement over time, so he decides to draw one. He knows that a line graph has a horizontal and vertical axis, and that the time data is usually shown along the horizontal axis. So have a look at the graph. Where it says time, that's our horizontal axis, and it's also called the x-axis. The y-axis has been labelled distance in kilometres. That's our vertical axis. We refer to it as the y-axis. So we've got an x-axis and a y-axis. Now, I want you to get your pointing finger. Can you put your finger on the y-axis? Excellent. Did you put your finger on the axis labelled distance? Fantastic. And now put your finger on the x-axis. Super. It's the one labelled time. Now looking at the table of data, what scale interval do you think should be used on the horizontal axis and vertical axis? Do you think we should go up? You can see the data has been recorded every 20 minutes. We can see how far he's travelled. Should we record the data on the line graph is every 20 minutes, or should we make the intervals smaller, shorter? Well, Camille decides on a 5-minute interval scale. for the horizontal time axis and a 2 kilometre interval scale for the vertical distance axis. So his x-axis, he's going up in 5-minute intervals, and his y-axis is going up in 2 kilometre intervals. As he is creating the scales, Camille makes sure that the numbers are positioned on the lines of the axis. He doesn't label every interval on the axis. Camille's line graph also needs a title. What would be a good title for this line graph? Well, he comes up with this: a line graph to show the distance travelled during a sponsored cycle. Perfect. It tells the person looking at the graph exactly what information is shown. So you'll see here where the red arrow is pointing at the bottom on the x-axis, that is a 5-minute interval. So that would be 14:05. If we were to go to the next line across, it would be 14:10, 14:15, 14:20, 14:25 until we get to 14:30. And where the second red arrow is pointing on the y-axis, that represents 0.2 kilometers. So 0.2 kilometers is represented as we go up. So 0.2, 0.4, 0.6, 0.8, 1 kilometer. Okay, so he's going up in 0.2. Now Camille is ready to plot the data from his cycle ride onto the line graph. So you can see he locates the time values from the data table on the horizontal axis. He finds where these horizontal lines intersect. That means they cross over with the distance values on the vertical axis. And then he marks each intersection with a small cross. So although it's a line graph, he starts off by plotting all of his data onto the graph first. So we can see at 1400 hours, he hadn't travelled anywhere, he just started, so 0. So he needs to find where that matches up. It's a bit like when we're doing coordinates in class. You're finding where they match up, and then you plot that coordinate there. Next one is 1420, and at 1420 he had travelled 1.2 kilometres. So you can see he's plotted that onto the graph, and so on and so forth, until he's plotted all 7 onto his graph. Now, he isn't finished there. He then needs to draw a line. He needs to join the plots together with straight lines to create a continuous line. So he uses a ruler to do this, and with his ruler he draws a line from each point to the next point. Okay, so it might not look like he used a straight line. He used a ruler, but he did. He's used a ruler to plot it, and then once each coordinate or point has got to the next one, then he's had to change the direction of his ruler to line it up with the next point. So now we're going to have a go at seeing whether some information is true or false by reading the information shown on our line graph. So I hope you're ready. Let's go. Camille said that by 1450 he had cycled 2.6 kilometers. Is that true or false? Have a think. Look at the graph. Is it true or false? We can see that 1450, first of all, we know that if we're talking about 1450, we're going to be looking at the time, so the x-axis first. So we find 1450 on the x-axis, and then you'll see where the green arrow is pointing up, pointing vertically, that's the direction we're travelling in. And we follow that line, once we found our 1450, So we go to 1430, 1435, 1440, 1445, 1450, and then you need to travel all the way along the green line until you hit the purple line. So you follow that line all the way up until you meet your line. Once you meet your line, you change direction, and we're going to travel horizontally until we meet the line on our y-axis. Then we need to read how many kilometers he travelled in that time. So we know if we go from the 2 and then we're going up in 0.2, so 2.2, 2.4, 2.6. So at 1450, had he travelled 2.6 kilometers? Yes, he had. It is true. Let's try another one. Camille says it took me 1 hour to cycle 4 kilometers. So go from 1400 hours, which is when he started riding, and we know we're looking at the time between 1400 hours and 1500 hours to see whether or not he had cycled 4 kilometers. So we're going to go to 1500 hours first. We travel all the way up until we hit the purple line. Then we change direction until we hit the y-axis. You can see the number shown before is a 3. So if we add 0.2 to that 3, we get 3.2. So we can see now that at 1500 hours, he had travelled 3.2 kilometers. So that is false. In fact, it wasn't until 1530 that he had travelled 4 kilometers. Okay, so it wasn't until half an hour later. It took him 90 minutes to travel 4 kilometers. But in 1 hour, he'd only travelled 3.2. Well done if you managed to get that. Let's have a look at another one. From 1430 to 1500 hours, I cycled 2 kilometers. So we're going to be seeing how much he travelled in that time. So, just as we have been doing, I'd like you to find 1430 on our x-axis, put your finger on it, and follow the line all the way up until you hit the purple line to represent his journey. Once you hit the purple line, change direction and travel towards the y-axis, and then record how far he had travelled at 1430. That's right, he had travelled 1.6 kilometres. But we're not finished there. He says he cycled 2 kilometres from 1430 to 1500 hours. So now we need to go to 1500 hours. We can see that at 1500 hours he had travelled 3.2 kilometres. But we're not finished yet, because we need to work out the difference. The difference meaning, if I take away the lesser number from the greater number, what do I have left over? And that tells us the difference. So 3.2 minus 1.6. Is that 2 kilometres? No. He had cycled 1.6 kilometres between 1430 and 1500 hours. So that is false. Let's try another one. It took me 30 minutes to cycle from 4 kilometres to 4.8 kilometres. Can you try and do this one on your own? See if you can read the line graph to find the information that you're looking for. Fantastic. Let's go through it. So this time we're starting from the y-axis, and we're seeing whether or not it took him 30 minutes to cycle from 4 kilometres to 4.8 kilometres. So we can see 4 kilometers he'd cycled 4 kilometers at 15:30, which is the same as 3:30 p.m. Then he says he took him 30 minutes to cycle an extra 800 meters. Let's see if that's right. Well, 4.8, he did that by 15:40. Is the difference in time from 15:30 to 15:40 30 minutes? No, that is false. It took him 10 minutes. Well done if you managed to get that one. So, now you're experts at reading line graphs. I want you to have a look at the work that was sent to you this morning, and I want you to answer the questions on reading, interpreting, and understanding line graphs. Don't worry if you can't draw a line graph or anything like that at this point, because that's what we're moving on to tomorrow. But our focus today, and hopefully by the end of this lesson and by the end of you completing your task, you'll feel confident being able to read line graphs. Remember, line graphs are used to present information to us. As usual, we would love to see your work, so please remember to email us your work at the email address shown. Have a fantastic day. Bye.